Yes. Hello guys. Today I will talk about what are the polar coordinates. Alright. How it is different from Cartesian coordinate system. That is one of the points. Then after polar coordinates, there are certain other points. So there are 5 topics today I have to discuss about first. Then I'll take these questions one by one. There are 12 questions here that I have to discuss. Okay, but before that I have to talk about what are the polar coordinates. Then angle between radius vector and tangent on the point given, and after that we will discuss about what the length of the perpendicular from the pole to the tangent at that point. Then the last 2 points are what are the polar subcoordinate subtangent and what are the polar subnormal. So these are the 2 other points. Okay, so we will discuss today. I have to discuss today the 5 points here. What are those 5 points? Let me discuss them one by one. First point is what are polar coordinates? What are the polar coordinates that I have to discuss about today? Okay, so this is the first point. What are the polar coordinates? This is first point here. Second is angle between radius vector and the tangent This I will discuss about. Third point I will discuss about length of the perpendicular. Length of the perpendicular from pole the pole to the tangent at the given point. This is the third point here. Okay, and then I have to talk about what is this polar subtangent. What is the polar subtangent? Okay, polar subtangent. What is the polar subtangent? And then this one, what is the polar subnormal? This is the next one here. Okay, so these are the 5 topics of today. So these questions are based upon these. I have to take one by one, but I am taking them in summary in all the points together so that one can understand that how they can be differentiated. So what is the difference between these points separately? Okay, so and then in the next lecture I'll talk about what is the angle between 2 curves, which are discussed in Cartesian coordinates as well. But in this case, in case of polar coordinates, we have discussed what is the angle between 2 curves. Okay, in case of and what the angle expressed in terms of polar coordinates. That is the next topic. Then the pedal equation. For the pedal equation that I will discuss in the third one, next lecture. So these are the total points of normal and tangents and normals. Then this topic will be over. So let me take today. What are these points? Okay, so let me discuss one by one. So first of all, let me discuss what is the polar coordinates and how they are expressed here. Now, polar coordinates, let me discuss first, because that is the main point here. The polar coordinates. Now, besides Cartesian coordinates, let me introduce first. Besides Cartesian coordinates, we can express the position of a point in a plane can be expressed. It can be indicated in the terms of a length of it from a fixed point and the inclination of this line or this point P, from a fixed line. So let me draw a point here. So first point, what are the polar coordinates that we discuss? Suppose there is a point O here, and this is OX, a fixed line. From this there is a point P here, is the position of which we have to express in terms of r and theta. This r is the length of this point from the fixed point, okay, up to this point here. Okay, so this angle is theta. So the position of P point can also be expressed in terms of the length of it from a fixed point and the inclination theta with the initial line, okay, or with a fixed line OX, which is known as initial line. Okay, let me discuss this. What are the polar coordinates? So first is polar coordinates. Why they are known as polar coordinates? Okay, as I have expressed that besides Cartesian coordinates, the position of a point P in a plane can be indicated or expressed in terms of the length of it from a fixed point, which is r, okay, known as radius vector, and its inclination, the point's inclination along this line, okay, from a fixed line, okay, at what angle it is inclined, okay. In these two positions, the r and theta, the position of this point can be expressed. So they are known as polar coordinates. Now let me write this whole so that one can understand. So let me start from this. Besides Cartesian coordinates, the position of a point P in a plane can be indicated or expressed in the terms of its length r from a fixed point O, here it is O, and its inclination, and in terms of its inclination theta, okay, from a fixed line OS, in this case OS, that which P r theta is the point in a plane, okay. P r theta is the position of the point, P from O, from which its distance is r, known as a radius vector. This is vectorial position known as radius vector. Okay, and its inclination theta is from a fixed line, okay, or at the fixed line OS, on the fixed line, inclination theta from a fixed line OX, known as initial line. Okay, and theta, the angle, is known as vectorial angle. Okay, so these are this is radius vector and theta is vectorial angle. So these are and these 2 points are known as polar coordinates. So these points r theta, or this point, this point r theta, these points r and theta are known as are known as polar coordinates. Are known as polar coordinates. Okay, are known as polar coordinates of the point P. Okay, in this case, P point. These are the polar coordinates in this case. Okay, r and theta are known as polar coordinates and expressed as P r theta. So we will express this as P r theta. Now let me take other point. What is then position of it? Positive or negative? Let me start that. Okay, so if let me take the position of it, how it's positive or negative. Okay. So length r, let me express this. Okay, and this whole angle, this one, is phi plus theta. This complete angle from this point to this is pi plus theta. This is phi straight angle, and this angle is theta. So added as pi plus theta complete angle, and this is opposite to this P OP. This is OP I've taken OP, and this let me take OP dash. Okay, so the length R is positive along OP, which is measured, okay, in the direction, right here, in the direction of OP bounding the angle, bounding the vectorial angle theta, bounding the vectorial angle theta. So along this, which is bounding this angle, vectorial angle theta, okay, so that is positive direction, and opposite to this, and is negative, R is negative, opposite to OP, or in direction to OP dash, or in the direction, or in the direction OP dash, just opposite to this. This is negative direction, this is positive direction. Okay, while the vectorial angle theta is positive, in the anti-clockwise direction, measured in the anti-clockwise sign, okay, direction, or in the anti-clockwise direction, you may say. That means in this way it is positive, opposite to this it is negative. Okay. Now this is something about negative and positive R, when theta is positive, when R is positive, that I have expressed. Now let me talk about if the value of R and theta are given, if the point, further note, if values of R and theta are given, okay, are given, that is the point R theta, if it is given, then position of P is unique, or it is only one point. Position of P is 1. That means P r theta is given to us. With value of r and theta given, then P can be expressed only uniquely like this. There is only one position of P in that case. But if only P, if P is given, that is the point, that is the point P is given, then its position can be either r theta or r theta plus minus 2 pi, okay, r comma theta plus 4 pi plus minus 4 pi, and so on, and or either this or this or all these things or this, or it can be minus r theta plus minus pi, comma, or it can be minus r theta plus minus 3 pi, means in odd multiple of pi, okay, theta plus minus 3 pi plus minus 5 pi, etc. So this is in case of negative r is given. Then these angles are there, okay, in the opposite direction of this. So this is the position of, this is the position of one of these position, maybe of r or maybe of P, the point P. So P, if it is not properly given, then we have to find out value of P. What is the position of P? Find out. Okay, then it can be one of these points. Okay, so this is how the point P can be expressed out of these points. Okay, so now let me talk about what is the relationship between Cartesian coordinates and polar coordinates. So relationship between Cartesian coordinates and, okay, fine. Now let me relation between let me take relationship between polar and Cartesian coordinates and Cartesian coordinates. Okay, what is the relationship between polar and Cartesian coordinates? That let me express. If this OX is considered as the axis of x, okay, the line perpendicular to OX, which is considered as the y-axis, I can take this as the y-axis. This is y-axis. O is the origin, OX is origin, and this is the radius vector undoubtedly. So that can be expressed, and if I draw a perpendicular from P upon the axis of x, this is a straight line I have to draw. It is a straight line, and take a straight line here. This is, let's take M. This is right hand. Okay, so this distance is, let me take the Cartesian coordinates of this is r, x, and y. Cartesian coordinates of P, if x and y are given, then what the position of x, y in terms of r and theta, that we have to express the relationship. Let me write here. If OX is the axis of x, and a line perpendicular to OX is y-axis, that is OY as the y-axis, okay, and let Pxy are the Cartesian coordinates, are the Cartesian coordinates of P. X, Y are the Cartesian coordinates of P. Then draw perpendicular PM, then draw PM perpendicular to OX. Okay, and therefore this is the Y coordinate from this point to this point. This is X coordinate from origin to end point. This we know from Cartesian coordinates. Now what is the expression in terms of r and theta that I have to express? Therefore, in triangle, right angle triangle, in right triangle OPM, we have PM upon, we have to express this relationship in r and theta. Okay, so we have to include r in radius vector and angle theta. Okay, so in expression of that value of x and y we have to find out. So PM, this PM divided by OP is equal to sin theta. This we know from trigonometry that perpendicular theta is side opposite to angle. This perpendicular, this is base and this is hypotenuse, side opposite to right angle. So that is hypotenuse. This is hypotenuse, R is hypotenuse in this case. So PM upon OP is sin theta. This implies that PM is equal to OP into sin theta. OP here is R sin theta, and PM is Y. So Y is R sin theta. This is first expression. And OX, this is the base here, sorry, OM. And OM upon OP is equal to cos theta in this case, based upon hypotenuse. This implies that OM is equal to OP into cos theta. OP is X, so X cos theta, and OM is, this is R cos theta. OP is R and OM is X, so X equal to R cos theta. This is second equation. This is the relationship between polar coordinates r and theta and Cartesian coordinates x and y. So here y is equal to r sin theta from this equation, and x is equal to r cos theta. So this is the relationship between Cartesian coordinates and polar coordinates. Okay, so and if we want to transpose the Cartesian coordinates to polar coordinates or vice versa, polar coordinates into Cartesian or Cartesian into polar, this relationship will give us that transposition. Transformation. So this is what we call, this point is there. So finally we have got x equal to r cos theta and y equal to r sin theta. These are the polar coordinates and Cartesian coordinates relationship. So from these relationships, one can transform Cartesian coordinates into polar coordinates, into polar or vice versa. Okay, or polar into Cartesian. This is the relationship between Cartesian coordinates and polar coordinates. Now, next important topic is point is of this lecture. Let me talk about angle between radius vector and tangent. It's very important topic. The second topic we have to discuss about angle between the radius vector and the tangent, and the tangent upon the curve in that point. And the tangent on the curve given at the point P. This is in polar coordinates, P r theta. Okay. Tangent we have to draw at P r theta. Now let me take what is P r theta. Okay, so if I draw a tangent on a curve, let me take this curve as this is the tangent we have taken. Now this is the P point here. We have taken 2 points on the curve. Let me take P r theta and Q here. This is r plus delta r and theta plus delta theta. This is Q point here on the curve. Okay, and this is the radius vector r, and angle is theta. We have taken of radius vector. Okay, then if I draw tangent upon P, this will give us tangent upon P. Let me extend it into a straight line. Okay, this is the point P here. Okay. Tangent at point P. This is the point, sorry, on P here. Let me take this as and this point P. So point P is here. Curve are taken a proper okay, the P point. Okay, and an angle between this tangent, let me take tangent and this radius vector, angle is phi. So we have to find out angle between this radius vector r and the tangent. Let me say pt tangent, and here it is t dash. If I draw a perpendicular from Q to this radius vector, okay, this is OP, which is extended meets at M point. This is the radius vector. Okay, so this angle is phi. Angle between this is, let me take T point here, T dash point. Okay, this point is T dash. This point is M. This is a right angle. Right angle. Okay. So if I just take O, okay, and join this Q to O, and let Q is inclined at an angle, this delta theta angle. This is delta theta. Okay, so delta theta angle. If I express this, let me again express this in a proper manner, in bigger sense. Okay, so this is the point P here, and the radius vector, this is the radius vector. Okay, this is the P point here, and tangent upon this point, if I draw, and this is the tangent upon this point. Okay, and this angle between them is phi angle. If I take P point here, sorry, Q point here, which if I join, this is Q point. Q coordinates are r plus delta r and theta plus delta theta. So what does it mean? This means this total length of it is okay, this is a straight line, and this angle is delta theta. This is theta. Okay, and this is the tangent PT. Now let me take P here, that it can be clear. This is P point. This is r theta. The position of this P point along this radius vector r, this is radius vector r, this value is r per delta r. PQ, so OQ is r per delta r, OP is r, okay, and tangent, okay, tangent is, this is, okay, and tangent, let me further draw. Okay, so if we draw a perpendicular from Q on this radius vector OP extended at M, which meets extended M, this is T point or T dash point, this is Q point here. Okay, so Q, T dash and M, the 3 points here. M is on radius vector. Now let me, so this angle, this is phi angle. The angle between the radius vector OP, OPM and the tangent TP, T dash. So this angle is phi. Okay, so angle phi. Now let me solve it. Find out relationship between, what is the angle between radius vector and tangent. So phi, value of phi we have to find out in terms of r and theta. That is our main objective here. Okay, so the main objective is this. So now let me find out what is the difference between. Now in this case, this delta theta, this angle is, let me write here, this angle is delta theta. Okay, the angle between the angle QOP, this angle QOP or this QO, yes, M dash, QOM dash is delta theta, while angle this POT is angle theta. This is theta plus delta theta. Q is lying at angle theta plus delta theta, and P is lying at angle, when inclined at angle theta. Okay, this is O. Okay, and OX is the initial line, as we know from polar coordinates, and r theta is this. But let me take expectation. Okay, if P r theta and Q r plus delta r and theta plus delta theta are the 2 points on the given curve. Let me take this curve is r equal to f theta. This curve is, okay, this curve is, let me take this curve r equal